You've heard of the notoriously brain-melting twin paradox, right? The thought experiment involving time dilation and Einstein's theory of relativity that is so utterly paradoxical, it seems to turn our basic understanding of how time flows on its head. Well, let's start by clearly laying out exactly what this famously befuddling paradox entails. The twin paradox goes like this. Imagine we have two identical twins, sisters let's say, born at exactly the same moment. One sister stays on Earth, living an ordinary life at regular speeds. But the other sister embarks on an epic journey through space aboard a high-tech rocket capable of traveling mind-bendingly close to the speed of light. Now, according to Einstein's special theory of relativity, thanks to the bizarre effects of extreme velocities approaching light speed, the traveling sister should experience time dilation effects that make the passage of time appear to dramatically slow down for her relative to her earthbound twin sibling. The laws of physics get downright freaky once you start flirting with the cosmic speed limit. So from the perspective of the stationary twin sister watching her sibling rocket off into the cosmic abyss, her traveling sister should age much more slowly and experience far less total elapsed time over the course of her interstellar voyage that could last decades. Relativistic time dilation would turn the voyaging sister into a paradoxical cosmic Rip Van Winkle of sorts. But here's where the paradox arises that scrambles our logical brains. From the perspective of the traveling twin aboard that supreme velocity rocket ship, it's actually the Earth and her stationary sibling that appear to be zipping along at an appreciable fraction of the speed of light in the opposite direction. And based on those very same rules of relativity, that means the earthbound twin should be the one experiencing a slower subjective passage of time and aging less compared to her rocket-riding sibling from her reference frame. It's a maddening contradiction of perspectives that makes zero sense no matter how you frame it. We now have a scenario where, by the laws of physics, each twin should logically experience the other aging at a dramatically slowed rate based on their velocities relative to one another. It's an utterly bewildering paradox that shatters our common sense notions of time being a universal, constant flow agreed upon by all observers. The twin paradox reveals how relativistic effects at extreme velocities produce scenarios that defy our innate logic and basic intuition about the linear progression of time and aging in the universe. If time travel at these surreal cosmic speeds was actually possible, the twin paradox implies there would be a complete breakdown in our scientific understanding of the coherent passage of time itself. So if time dilation effects like this are real, how can this paradox be resolved? How can we make sense of each twin's perspective aging the other at a faster and slower rate simultaneously? It seems to violate the fundamental rules of reason itself. Well, as mind-melting as the twin paradox is on the surface, physicists have proposed potential resolutions that dissolve the paradox in ways consistent with our modern understanding of space, time, and relativity. Let's dive into some of the key solutions. The Relativity Resolution. According to Einstein's theories of relativity, the alleged paradox isn't actually paradoxical at all when you understand how time dilation and the perception of elapsed time works across different frames of reference. From the perspective of an outside observer in their own inertial frame, they would see the traveling twin experience less elapsed time due to their high velocity, while the earthbound twin appears to experience more elapsed time. This is entirely consistent. There's no contradiction. The acceleration factor. One key aspect that resolves the paradox is recognizing that the traveling twin is the one who has to undergo acceleration to achieve that high velocity and then deceleration to return to Earth. The earthbound twin remains in a continuous inertial frame. Acceleration causes a further contraction of time from the perspective of the accelerated frame according to relativity equations. So the travelling twin really does experience less total elapsed time when you account for both velocity dilation and acceleration effects. The changing inertial frames. From the Earthbound twins' perspective, they remain in a single inertial frame the whole time. But the travelling twin is the one who has to undergo a transition between multiple inertial frames on their journey out and back. This changing of inertial frames by the travelling twin leads to a sort of stitching together of multiple time-dilated windows, which desynchronizes their cumulative elapsed time from their Earthbound sibling. The paradox arises from trying to map the two perspectives onto a single inertial frame. So in summary, while the twin paradox may seem utterly contradictory at first glance, physicists have clarified how effects like acceleration, changing frames of reference, and the intentional mapping of perspectives allows for a consistent resolution within our modern theories of relativity. Once you grasp those factors, the paradox dissolves. What's your take on this delightfully confounding paradox and the proposed solutions meant to resolve it? Let me know in the comments below, and feel free to share any other famously brain-twisting paradoxes you'd like me to try and solve in a future video.